You guys, I have that Zoom session going if you want to connect to it, because we'll use that to show our scratch games. And I'm always showing the attendance here because I want you to notice if I count you absent by mistake, so I can fix it. I don't think I've got anybody by mistake, but that's why I keep showing it to you. So I'm seeming like that space cadet teacher that just doesn't realize it. No, I am that teacher, but not in this instance. Here he comes. Okay, let's see who this is. Daniel. Got it. Playing games, I hope. Scratch games. Good, good. So that's the first thing we're going to do today is look at everybody's scratch project. So a couple of things before we do that. Amazon's making weird noises for me.
Professor?
Yes?
Colin Gill is here. I'm just, I'm feeling sick, so that's why I'm on here on Zoom.
Okay. So send me an email or something beforehand, please.
Okay, sorry about that.
That's all right. This will help me out a lot. So many places to look. All righty, we got you. Thank you, sir. Okay. So some of you in class, you might be interested in getting your own keyboard and mouse, and I just brought it up on Amazon just to kind of show you that there are some out here that are pretty cheap. He's got one today, and it's a nice clicky one. And so he's feeling all embarrassed because it's clicking, but I love those clicky ones. I don't know about you guys, but all these silent ones just are kind of spooky. I don't feel like any work is going on. So a clicky one won't bother me, but The mechanical keyboards are a little more expensive and are a little bit harder to find in a wireless model. So this one I just clicked on, and the reason why is because it's Logitech. And you guys, whenever we're working with wireless keyboards and mice, there used to be kind of a conflict where we would have a limit of only being able to have like 8 or 10 in the same room before they start interfering with each other. And Logitech guarantees that that's not going to be a problem. So I'm not a brand specific person, but I do like the fact that they say you can have 70 or 80 of their keyboard and mice sets in one room without any problem. So this is just something if you're interested in, you know, if it's been making you worried to be using the keyboard and mouse, you might be interested in getting a wireless option. This one is $25. It's a little bit more pricey than some of the cheaper options, but again, those aren't Logitech. If you do get one, feel free to use it. All of the computers should have this little USB extension cable available. You can use that for a flash drive, or you could use it for that wireless dongle if you got your keyboard and mouse. So whatever you wanted to do with that. I just kind of wanted to mention it. Oh, and here's the problem I found. They say that Logitech will allow you to have up to 78 users in a 10-meter range. So it can be an issue for us, like if we're at a big event or something, but we should be fine. I didn't think we would be, so I'm glad to know that. All righty. I think I'm going to go ahead and invest in one. I don't even think there's a lot of other people sitting up here, but I make a lot of typos with these super quiet keyboards. Gosh, you guys, the keyboards are just not conducive to me getting work done. Wine. How was everybody's long weekend? I haven't seen you in like a week. Was it good? Get a lot done? Lots done. If you go to Canvas and go to our discussion board, you can bring up all of the scratch games that have been posted. I'm going to go just down the discussion board, asking each person to show us their game. And it might be a video type thing, that's fine. Either way, I just keep saying it's a game. Now, the reason why I'm going to have you show your own is twofold. First of all, because I want some information from you. So when you start to show your game, if you would, remind us all who you are, what your name is. Again, hard to remember names and faces when we can only see a little bit of them. Your plan. What was your plan for your Scratch application? Were you going to make a side scroller type game doing blah, blah, blah? Or were you going to make a video? Just kind of let us know what your original plan was, if you had one. And then how did that equate to your reality of what actually happened? Were you able to implement your plan? Or did you have to kind of change things as you found out the capabilities of Scratch and you ran into some issues? Everybody will be interested to know what you ran into. And then we'd all like to hear about a success, because when we're working with computers, sometimes we say, oh, and then this terrible thing happened, and then this terrible thing happened, and then I got stuck here, and that's normal. So I want you to kind of flip that around and say, when this terrible thing happened, I persevered and I beat it and I won. So let's focus on the successful side of it. So that's what I'd like from each of you as we go around person to person. If you look in our discussion board, like the first one of Bronson's is not a link, that's okay. If you just select that URL in Canvas, you can right click on it and choose go to that URL. And so it's like just the same as a link, so we can get there pretty quickly. So hopefully everybody's will work. And I think we're ready. Any questions before we get started? Oh, good. Okay, let's start with Bronson's. And I'm going to shut this back. Oh.
Do you want me to take over the sharing thing?
Yeah, that's what I was going to say. I didn't say. Remember, you're just going to find your Zoom toolbar and click on New Share. Let's make sure everybody's in our Zoom session first. And then once you've got your Zoom session going, you're going to find your Zoom toolbar, and we want the green new share option. And then you're going to pick probably that very first option that it shows you to show your whole desktop. And then we'll be able to see what you're doing. You won't be able to do that until I stop the share. We have 16 people in, so we need a few more. Remember, the URL to our Zoom session is on our home screen in Canvas and also on our syllabus. Getting there? We don't have too many. Now, the first one is Bronson, and he mentions that he did this a long time ago. And that brings up something that I always try to remember to say to classes, and sometimes I forget. If you have had a lot of experience in programming, you're welcome to talk to me and ask for an alternate assignment. But if you don't want to do that, then take the assignment and expand it. Make it harder. Don't just do the assignment that the entry-level people are doing. Challenge yourself, add to it, put in comments to let me know that you did that, but always be trying to challenge yourself. And he actually says it in here. He'll probably try to work on something new, because we've got to constantly be challenging ourselves. You know, if we did something when we were a sophomore, we can't just say, oh, I've done that already. And actually, I do that a lot because I teach entry-level programming classes. So I'll write that same program again for the 50th time. And usually every time I do, I figure out something to make it better. So even though it might be a real small program and I've already written it a lot of times, I still usually figure out a way to do better every time I do it. So take that into consideration if you've got a lot of experience. Don't let yourself get bored, because it's going to be kind of up to you to challenge yourself. If I can tell you, our new people that don't have any experience will be challenged without doing that. So it's a thing. Okay, let's try this, Bronson. You should be able to take over.
All right. I'm Bronson Carter. This is my game, Scratch Cat versus Balloons. I wanted to make like a point and click, like shooter type thing. Unfortunately, the Scratch doesn't seem to have a way to do on click, so I tried to make it a press buttons to shoot. But it worked. Let's see. When I first made it, it was just balloons popping up on the screen. It was kind of boring. So I added a scoring system, some levels, and the life system. Anytime a balloon touches you, you lose a life of your 9, of course. But, every time you get another 100 scores, it goes up a level and balloons start popping up faster. I'm not very good at my own game. I think I've only ever won this once. But yeah, and then after 400 balloons will stop spawning, and it'll ask you to clear the screen, and then if you can clear the screen, you won. But again, I'm not very good at that. First couple levels don't go very fast. Yeah, just points at the direction your mouse is pointing, and then you press a button to shoot. I find this is kind of fun. Pretty basic, but
Fun.
like the whole thing. Is that good, or I don't know.
Looks great. Yeah. Can we see inside of you, and let's see your awesome code?
Sure. Okay. Most of it I just did on Scratch the Cat here, I think. I guess a lot of it on all that, I just spread it out. Okay, so yeah, when you click the flag, it waits until level 5. Oh, wait, that's okay. Yeah, that's just to ask you to get the screen. This part is for if you die, it says sorry you lose, and then it says press the green flag to play again. At the beginning, it says press any button and sets your score and set to 0. And this is how it calculates the level. And this is oh yeah, okay. This is how it shoots. It creates a clone of itself. Lets it sound pop.
Oh, cute.
Honestly, it's been a while since I did all this. I don't remember what some of this even is.
That's okay. I'm going to be happy you said that here later. Okay, so notice how when we're using Scratch, we've got this code associated with like a certain event or a certain character in this case. So our code is kind of separated, right? It's not just all one big set. And we'll probably see some people who did it that way, and that's okay. And that's why we want to look at the code. So we're not really asking you to analyze it or anything like that. I just want you guys to kind of compare how there were so many different ways to do things. So this is just our very first way of looking at, so we can let him off the hook. We enjoyed it. It was a great game. Let's give him a hand. Yay. And let's see what we have next. Asin.
Hello, my name is Ashton, and this is my game. I'm not real creative, so be more good. Is the name. Basically, is go around fucking point. My original thought when I went into this is I wanted to create a side scroller, you know. But what I didn't realize is that that's an advanced brush concept. So my level, I can only move the ball around and like the queens. Much. Isn't that bad? That's where the name came from.
Good. Okay, let's see that code.
So basically, my whole thing for life centers around if loops, what I like to call. Everywhere there's a forever if. It doesn't really matter much, but makes it a little messy.
It's not bad. And then
just sets everything up, makes it all go to the center, zeros all my counters, and then defines time, which is basically things. And since motion is a forever loop, you can't add anything after it, so you just have this little guy floating around.
Cool.
And this guy is just setting up levels. Time equals this. Here's the coin, which the actual coin is just going to sit in a corner hiding forever because it's a coward. What's actually being played are the clones, which goes around just flooding, taunting, begging you to collect it.
Great.
And then basically this sets up how many coins appear. Which I'm doing pick randoms because there's got to be count in it. And level. And that's just does its costumes, which have it rotating.
Okay, so There's your Sprite costumes. Awesome.
This is just the end screen to make the beginning and end look neater. This just shows all the variables, stops it all, so you don't have to press the little red off gun.
Nice.
And more code here.
Like it. Like it.
And this is the website's claims. So, it's things.
Nice and clean. Different chunks. Let's give him a hand. Yay. And Daniel.
So, I'm Daniel.
Yes. Hey.
This is my crush. Yeah, still working on it. Trying to like make the trying to make the soccer young kid here run with the ball to the post. Well, it's been very hard for me to do, so I'm still working on that. That's quite hard of it. Cool side actually. Basically, what I'm trying to do is to make the ball and the guy walk towards the post together. But at the moment, I can only make the ball itself go only itself. But I'm still working on making both of them move at the same time to the post. So,
Good.
so far, this is what I've done so far.
And I'm sure that there's some other people that could help you because you have to have the code associated with both sprites. But I think that that's a really good thing for you to be working on throughout the semester, because if you can focus on it on your own and really figure out how the things are interacting and get it to work, I think it's really going to help you with the other coding that we're doing. So I don't want you guys to feel like you didn't do enough, because we're all starting in different places. And so sometimes, you know, if you're starting way up here because you've already had all these experiences, that's a different place. So Daniel is just getting used to the idea of the sprites and the code being associated with the sprites, and that'll be a good process. So let's give him a hand, because learning is tough. We all know it is. Thank you. Okay, next, Connor. Connor has directions posted. You better play it well. Daniel, you're going to have to drop that share for him to take over.
Alright, I'm Connor, and mine started out, it's supposed to be like way over here, but he's not, I don't know why. But it's supposed to like rotate, and then you catch the apple.
Are you Connor?
Yeah.
Or are you Colin?
Connor.
You're Connor? Thank you. Okay, and you're the one talking.
Yeah.
Sorry, I thought the person behind you was. I've not gotten that confused yet, but our room is full. Continue on. Don't let me bother you.
I don't know why you didn't start with way over here like you're supposed to, but it's fine. And then you gotta like click that, and then I don't know this one. The 0 is changing it, the backgrounds, and then you show off the screen. You're supposed to like jump up and land. Yeah, start over here. And click that, and moves 100 steps towards the tree. just press the space to rotate him, and up, go up to the tree. And then he does like a kind of like a backward thing. Then you press 0 and down arrow at the same time. So it can change, you can grab the apple and they can change the background. So two. On the apple and then keep rotating.
Nice. So is your code all one giant if statement there, or?
Yeah.
Is it? And so it lets you do it that way. I've never seen it that way before. So you're just saying if this key was pressed and we're at this position, do this. So it's just like one huge expansive if statement structure. Cool. That's a really interesting way to do it. Questions for him? Okay, give him a hand. Thank you, sir. Next we have Devin.
Okay, I am Devin. I made this game. Yeah, so you're Matilda. Yeah, Matilda. And the fairies are after you. So you gotta. She's got oranges, so you gotta throw the oranges at the fairy. You just keep doing that. And if you touch the fairy, you get put back to 0, and there's a ton of silly messages you get. But as I find, the fairy usually just ends your score, so it's more annoying to play than it should be. And then going into this, I had no idea what I wanted to do. I just threw stuff together, and this is what came out. So this is this first part's the movement, and all these 4 if statements, and then this one is if they touch the fairy, reset the score. And these are all the messages. We'll come back to those. And this is the orange. Let's see, this is just this if statement makes it always stay on Matilda. And then this one is to shoot, and it goes to your mouse position. And then this one is if orange touches the fairy, you increase your score by 1. So yeah.
Very nice. Interesting. I like it. Give him a hand. Logan?
I'm Logan, so I was kind of wanted to do like an interactive story. Here it is.
It's a trick. That they know.
And so
That's good. Let's see that code.
tedious, because like every time you started it, like you press on something and keep going, so I had to like have a thing to reset everything, so everything has its own reset button. And then there are a few other little sprites that I'm hiding that like at certain times, for example, whenever this sprite switch, it moves, and then it'll automatically move to the next thing. And so I had to do that a few times for a few different things.
Oh, that's neat.
I was originally wanting it to be more of like more interactive, but that was a little time consuming, so I just kind of made it automated just so that it could finish it.
Mm-hmm. That's great. Give it a hand. I love it. You're getting kidnapped. Ashley.
Silly little story. Actually, I didn't have a plan because I can't track our friends. I tried it once before, and my daughter said the thing that I made was really, really stupid. I was just like, okay, then, I can't figure out how to make this go full screen. So yeah, I just made this little horsey, and I'm very funny. So he's in a hayfield, and he's like, hey. And then he goes off the screen, and suddenly he's in a high field. He says, hey, isn't he? He starts sliding around, because it had to be 45 seconds. And actually, my other daughter, not the one who put the 100 and some, my younger daughter, she watched this and she sat and giggled through the whole thing. And she's like 18, so I think,
Poor horse.
it's too bad if she didn't get giggling. And then he went back to the naked, and he's like, what the hey?
Cute.
Like I said, I'm funny. Again, I had no plan, and I just started kind of thinking around and playing with it. And when I first started it, he kept, like he would, wherever he ended the last time that it was played, he would start there. And I didn't want him to, because then, you know, he'd be running all over the place in the sky. And so I put him here at that go to X so that he starts right where I wanted him to be. And then, yeah, really. And then when he went back to the hayfield again, I put him back in that same spot. So that he would be like upside down in the sky.
Neat. So in this case, you can see all the code. It's just straight through. It's going to start at the top and just go until it's done. So think about how that's just a little different than some of that code that's associated to specific sprites and specific events. There isn't one way that's right or wrong necessarily, but just think about those different ways that we can do things like that. So really good. Give her a hand. Yay. Next, we have Austin. Ashley mentioned that time limit I have. It's kind of mean. I actually had a student once who tried to recreate, I believe, the Bible. And we had to stop him after 45 minutes of class time of showing us his, because he had worked really hard, as you can imagine, on this thing that was never, ever, ever, ever going to end. And so it was kind of a bad time because I had to force him to stop because we didn't have time to watch any more of it. So to me, the 45 seconds is like, don't make it go on for 4 hours. Because sometimes people do. Okay, let's see this awesome one here.
Okay, so my idea was go sort of retro. I couldn't really think of something super original, so I went with the old good old Asteroids game. And I definitely need to work on the artwork. I need to add a few more sounds, but it does have sounds. And so Asteroids will come out, and I don't know why it's not shooting. It was shooting just a minute ago. But you shoot the asteroids, and whenever they touch you, you have 5 lives, and it'll go to 0 and go to game over. And I can maybe see why it's not working with the shooting. I think it's because I renamed the ship and the bullet. But the ship, whenever click, it goes to the center, switches back to backdrop 1, which is the black screen. Set your lives to 5, and then I've got all the directional movement, touching sprite 4 and 3, which is the asteroid. So when it touches it, it decreases the lives by 1. And then I've got the bullet, which when it's clicked, it hides it behind the ship. And then when it starts as a clone, and then plays the sound whenever it's fired. And then I started with one asteroid, and I did all the code for it to be randomized where it would go on the sides of the screen. And then I duplicated another one, and then just did the opposite of those numbers to have it go on the other side.
Cool.
That's it.
Thank you. Let's give him a hand. Yeah. And again, Awesome by kind of an accident illustrates why, as a developer, we're going to constantly tell you to plan, because renaming things after a certain point can cause a lot of trouble. And it's something that happens to all of us. And you see it even in Canvas when you look, where I've gotten a really good system, and then, I don't know, I'm gone for 2 weeks, and when I come back, my brain isn't there anymore. And I can go through and rename all of those, but it's a major undertaking. So it's best in any endeavor if we can have a plan so we know how we want to name things from the outset, because it can really be a problem for us to have to rename. Yeah, it gets very confused.
And I just tried it, and now it works.
It does work. Show us. We want to see it working. See that just being renamed causing trouble. You want to see your awesome game. There they are. Beautiful.
Each asteroid also has 2 lives, so you have to shoot it twice.
Yay. Fantastic. Give him another hand. Get it close. Got him. Debugging under pressure is always rough too. Okay, Zach Gilmore.
Okay. So I just made a little animation. So I didn't really have a plan going into this. I just kind of made it up as I went along, and this is what came out of it.
There's that hayfield. That's what the bear should have said to the alien.
So this gave me a whole new level of respect for animators because it was just extremely tedious.
It's
and I wanted
tedious.
to add like a dragon and Shrek and Donkey into it, but that was going to be like 6 other backdrops, and I was like, I don't have time for all this. So I ended up arranging each sprite's code by scene, like so. I had some trouble where some of the sprites would overlap with each other, but I figured out there was an option just to bring one to the front layer, and that fixed it pretty quickly. Otherwise, it was just like just figuring out how Scratch works. But that's basically it.
So each of the yellow options up there are different events.
Yeah, it just changes it from the backdrop.
That's really cool. Came out good. Give him a hand. Everybody loves it. Hey. The sound should come through if you say to connect your sound when you do your view. Could try it. I think we got one to work yesterday, maybe. All my sound is turned on though, so hopefully it will come through.
Okay, so I'm Jaylee, and I just created a little short story, which is nothing like what you did. Please don't hold me to that. But
What'd she say?
can I help you?
Mm. Just say no. Ah.
Oh, that says, do you trust me?
Again.
There was supposed to be sound, and there was supposed to be like a little magic spell, but I don't know why it's not working. So mine was just kind of like how Zach was, and I had to hide a lot of my characters throughout. They all have different little spots.
So does your sound work on your computer and
Yeah.
just not coming across?
I
Sorry.
don't know if I have the audio hooked up.
Yeah, it's being a real pain. So I loved it. Thank you. And Tim.
Alrighty. So my name's Tim, and I made this really simple, just ball bouncing game. And idea is to bounce the ball off pedal, and then when it hits bottom, you're supposed to get a game over. But I kind of ran into a problem with it, and the bottom gave me a game over, as you can see. So it just keeps on bouncing, bouncing, bouncing. So this is my code right here.
was really fun to make. Learned a few things on it. So one thing I had a really hard time with was trying to get the ball to bounce off the edges of the screen, and I spent about 10-15 minutes trying to figure out like the right math and what not to do. And then I found this right here, F on edge bounce, which saves a lot of time. And then after that, for whatever reason, I couldn't get this if statement to work right. If the white position on the ball is at a certain point, it should give you game over. Just stop all. But no matter what I did, I couldn't get that to work. So I was trying to call it good and turn it in.
Make you guys figure that out. Since he's using a forever loop, we need some sort of code to break out of that loop if he's touching the bottom. So if anybody has encountered that and you want to help Tim out, let him know. Should be able to break out of that loop. Or just say end or something. So I'll let you guys decide that one.
So those are like those variables.
Good thinking.
Yeah.
That looks awesome. I really like it. Kind of like a pong game. So give him a hand. Good job, Tim. And I am super proud of you guys because the number one thing I was telling my C#2 class this morning is when you have an assignment, turn something in. It may not be perfect. It may not be what you were hoping for, but don't not turn anything in, because I've seen people do that before where they get to be such perfectionists. And his game, of course, is really good and almost done. So that's an important point for us to realize. Next, Kyan, am I saying that right?
Yeah.
Okay. It's a cool name. I just feel like I'm saying it wrong.
Thank you. Okay. So my name's Kyan. This is my game. So basically, I was going for like a 2D side scroller shooter, and you can move this guy. And the problem I ran into was I was trying to get the milk carton to go like straight up from where you were, but it just kept going to the middle. And so you can't really play it. It's not really a game. I don't know why I called it that.
It's working on it.
Okay, so for the guy, these two right here, tell him to move. This tells him to spawn in whenever you get to the next backdrop, and you get to that backdrop by clicking the green button. The apple, this tells it to make clones of itself, and this tells like where the clones, it makes the clones go to random spots. I don't know what this is, so that's cool. Okay. And whenever it goes back to the button screen, it hides the clones. And the milk, these three down here, tells it to follow this guy. And this is what I have, like this is what I was trying to figure out to make it go straight up. Instead, it only went to the middle apple for some reason. So, yep, that's about it.
Neat. And Brandon.
How do I share my screen?
The green zoom button.
So I
I unfortunately didn't know that the requirement had to be 45 seconds, so I made a short animation. I've done a lot of animation outside of here. I just call it football. And it was really strange animating with code because I've never done that before. I've used 3ds Max, programs and applications like that, but this is what I made. It's called football.
It's kind of weird, isn't it?
Yeah, I'm not used to it at all, and this isn't very good. And then he goes, so it's about this guy. He's playing football with his buddy, right? He goes home to meet his wife and kids, only to find out that they have left him. And that's the entire animation. I'm really sorry for the short length. I didn't know.
It's okay. He's miniature too.
45 seconds when somebody just randomly said it.
Like I said, my time limit is to keep it short. So I'm okay with short. I don't want a 45-minute one. Is that terrible of me?
Like character depth thing about this guy, how he lost his wife and kids.
So you were ready, huh?
Yes.
Just wouldn't cooperate. Give him a hand. Thank you. We got some animation going. And Colin is at home. So we're gonna see if he can take this over. I don't know why it's showing it to you. Close that. Close that. Okay. Brendan, you'll need to release it. Your share there.
Oh, yes, the code. I'm so
And then
sorry. I
Colin can
forgot
get
all
it. No
about that
problem.
until now. So this is the code that I have. It's not very good, as you can tell. I mean, I've never programmed before, so this is like, I've actually done like programming before. And this is pretty much all that I made. I'm sharing my screen right now if you see it.
Yeah.
Okay, I'm just making sure it's working. Yeah. My expectation, so my plan was to make a short animation. And in reality, I did succeed in making a short animation. But I don't want to.
It's definitely not like the animation tools.
Oh, absolutely no. It's nowhere
So it's
near
very
anything
different.
like that I've used, which was really strange, like having to like manually like animate and move the characters, which is something I wasn't used to.
Mm-hmm.
That was the harsh reality I had to live with. And I managed to succeed in creating a short animation and making his wife and children leave him.
Yeah, and I know, Brendan, since you've used the real animation tools, you know how important it is to use the right tool for the job, huh? Because Scratch is really good for developing, you know, little game type things, but boy, animations are rough.
I'll be using it more. Thank you.
Huh? Are you good?
Scratch
Good.
more, yeah.
Try it. Okay, release that screen and we'll let Colin take over. See if we can see his.
Can you see mine?
It's getting there. Yeah, now we can. Ah, this is the greatest Scratch one ever. He was working on updating Scratch.
So, mine is pretty short and it's not anything special, but I'll go ahead and play it. So it's pretty short. It'll go there.
I love it. Oh man, it's missing it too.
Scraggly Scratch there. Looks like he's been on the streets of Springtown a few too many days.
All right. And so, can you guys hear me all right?
Yep.
Okay, all right, just making sure. So yeah, I was really short. I would have spent a lot longer on it if I had known everybody else's what everybody else's look like. So, but basically, I guess I kind of put more into the design than in the actual coding. Like I spent a long time working on the Scratch costume, but basically it's just the animation for him walking is switching between costumes constantly over and over again. And then him moving was pretty easy. It's just basically have to do it on repeats, and he moves 10 steps constantly. And so, yeah, that's pretty much it.
Yeah, and when you look at this, we can tell, you know, the sprite update on this one was a really important part, right? Because got the animation going, got the scraggly scratch going. So I mean, that was a really important part of it. So
Yeah, I don't know. I mean, like I've always been more into the design stuff, but um, I don't know. I could have done a lot more if. Yeah. So yeah, but
now you know. That looks
yeah.
great. Give him a hand. I love the scraggly scratch. Everybody likes scraggly scratch. Okay, I'm going to share my screen. I'm going to take over now. You guys did great. That was all of them. See if you're seeing my screen. Am I sharing? Yes, it says I am. Tell me if I'm sharing the wrong thing. Sorry, let me find the right window here. I have too many things open. I'm sure that never happens to you. I'm going to switch to student view and look at our modules. And in our modules, we should be going into week 3. So I'm going to make sure there isn't anything left over in week 2 that I need to complete. And sure enough, there is, because I don't use student view very often. So remember, we're looking for the things with the little circles over here under the complete all items. So under the overview, I need to mark it as done. And then I'm just going to click next because there are a few more. And of course, I don't need to wait for everything to load. I'm going to go back to my modules now because our discussion is kind of long and I want to see if there's anything left. Let's see, I've got check marks here. Whoops, that's week 1. Roll it up. Week 2, I'm still missing one. It's down at the very bottom, the summary. So I'll mark it as done. I have to put more in those to make it worth it for you. All right, so I should be able to see my week 3 stuff now. And our week 3 is pretty short, right? We just have this one day. I feel like it's day 5 or something more than week 3. But if we counted every day, it would just be overwhelming. So we're okay because in this week we're going to talk about program design and we're going to roll it over a little bit into next Monday. So we'll be working on these things today and Monday. The first thing in our week 3 stuff is, if you remember way back, I told you whenever you needed to install software, I would have instructions for you on how to do that. Let's look at this Microsoft Azure. And before we go there, I'm going to release the screen and I'm going to ask one of you to just grab it and show everybody how to do this because my setup is so much different than the student setup. One of you guys in the front, just grab it. So the Microsoft Azure for Learning site is just free software. And if you look at the instructions here on Canvas, the page here has a link to a video. You probably won't need that, but if you're at home and you don't remember the steps, you can use it. let's just go ahead and click on the link that says link. And this site is a Microsoft site. Right now, since you're on campus, it should have you click sign in, and it should log you in automatically. Well, it's going to do something different than what it did yesterday, which is normal. So use your OTC account to log in, and do use your whole email address. Yeah, you're getting it. I was like, yeah. You just had that everybody watching you thing. So yesterday in our other class, when they click sign in, it just automatically signed that person in. So you can see a little bit of differences. But this is better because at home it's going to make you log in. Now you're going to check and agree to the license stuff. And the second one and the third one have to do with spam. So if you don't want any emails from Microsoft, uncheck both of those. But if you would like to receive emails from Microsoft, leave one or both of them checked and accept. Now, when you get to the site, you have some options here. You have some student credits available for some Microsoft expense items. And Microsoft has a whole learning network out there. So there's all sorts of training and tutorials if you want to look at those. We're really interested in the free software. So click on download software. And all of this software is available to you for free from Microsoft. So the OTC CIS department has a subscription to this service, so you can get whatever software that you would like that you want to use. Now, in our class, the only software that we might use that you would want is Visio. So you could go up here and search for it. Just type Visio or here or either place.
Is it
VISIO.
Professional 2019.
Yeah, and you don't need to install this at home, but you could if you wanted to. Maybe this search down here. I think I've got you in the wrong place. There we go. So if I wanted the Visio drawing tool, I could just download from this site and get it at home. Now, on this site, you can also download for free Windows 10. If you get Windows 10, I think you get 5 copies, so 5 licenses. So for me, like I have 1 license on my desktop, 1 license on my old desktop, 1 license on a laptop. I still have a couple more that I could use. I know how to install Windows 10. So if you don't, you need to get a friend or somebody that does, because it's not going to be like a self-driven type thing if you don't know how to do it. But you can get Windows 10 for free. So if you buy a new computer, and my computer was $120 cheaper because I did not buy an operating system with it. I used my free Microsoft operating system to install. So Windows, when you take C#, Visual Studio Enterprise is out here, which is much, much more than the free versions that you can get online. So all of this software is available to you just because you're an OTC CIS student. So utilize it however you want. I just wanted to show you that it's out there. So there's that one. The next one then is the free Office. So let's go back to Canvas. And look at the next, well, go back to modules. It's in some weird order. And what I'm looking for is the Microsoft Office availability. Yesterday, we tried to do this in the other class, and the first thing, when we clicked on the link down here to get started, it crashed. Microsoft's always changing things. Try it. Put your OTC email address down there and click Get Started. Maybe they fixed it, but it probably won't. Nope. So let's open a new window and let's go find it ourselves. So open a whole new tab here.
Yeah, the thing is blocking it. So
Yeah, it's just wacky. So what's happened, Microsoft is always changing things. So all of their facilities that were set up to give students free copies of Office are still working. They just decided to change the name, right? Because we don't need Office to be named Office anymore. Now it's going to be named Microsoft 365.
Seriously?
Seriously. So search for Microsoft 365. And that's why none of the links are working, because they're right in the process of renaming it.
I have a question. What does 365 mean?
It's available 365 days a year.
Oh, that's what I thought that was.
Mhm. That's where it came from anyway, but it doesn't mean a lot for Microsoft. Okay, are you finding it? How dumb, they're just trying to make our life more stressful. So click on this Microsoft 365 one, not the login. Okay, so he's already logged in.
It's not letting me download it. It says sorry, we're unable to validate your access to benefits.
Right, because you don't want to do that here. You want to do that at home.
Gotcha.
That's why. But let me know if it still does that to you at home, because that's what it does to me.
Okay.
We'll try to get it fixed. But yeah, here the firewall is going to prevent you from doing it. Okay, so if you were at home and you weren't logged in at this site, when you search for Microsoft 365, you're going to use your OTC account to log in. And then you're going to have this button that says Install Office. And if you just click that button, it'll install Office. But let's do the drop down and let's go to Other Install Options. Because we're not just those kind of people that just take the defaults, right? We're developers. We've got to see what's going on here. So we want to know what all we have licenses for. So let's look at apps and devices. Again, with my Microsoft 365 account, I can have 5 installed. So I have Office installed on my desktop, my old laptop, my laptop, my old laptop, my phone, maybe my iPad. I don't know how many places. But I can keep track of that here on this site. And if I quit using one of those computers, I can release that license so that I can pick it up and use it someplace else, because I have a lot of devices that I need all this stuff on. Now, the other thing I can do here when I'm looking at the actual installation options is I can choose products like Microsoft Access. Microsoft Access is not installed automatically if I just click the button. So some of our other ones, I think the OneDrive gets installed automatically now. But if you use this option, then you can pick exactly what you want. Okay? So again, you don't need to install Office for this class, but it's going to help a whole bunch because I'm going to ask you to do Word documents and things like that without even thinking about it, because to me, it's just something that everybody has to do. Okay, any questions about that before we move on? Thank you, sir. I'm going to take that over. So lots of great free stuff. So as we look forward then in this week's assignments, we have quite a few things. The ones I want you to focus on before we leave class today, or after we leave class today, I should say, are these ones that are on your own. So the Chapter 3 review questions and the Python.
I had a question I wanted to ask. So today I was looking at campus and I saw the 9th, we had some kind of quiz we were supposed to do. It's a binary conversion.
Uh-huh.
We do a practice in class and then we take the quiz at home. Are we still doing that today?
We did it last week.
Oh, okay. I was just curious because it said September 9th is why.
Right, because when a week starts, your assignments are going to be due the following week.
Wow.
So it takes me a really long time to think about it. So really watch those due dates.
Yes.
Because if you have this date dyslexia like me, it'll be hard. So I have to really look at everything every single time and go, oh, it started on Monday, so next week it'll be due.
I'll be doing that tonight. Thank you. Yeah. I was like, wow.
It's like craziness, and it took me forever to get used to it, and I still do. Once in a while, I'll have to get the calendar out. So I will be really bad about not changing due dates because of that. Because boy, if I change a date, it just whacks me out completely, and then I'm all messed up with everything. So I don't sometimes students think I won't change due dates because I'm rigid. I am, because I'll mess up all the dates if I change one of them, so I have to be. So these are the two that you should be working on over the weekend, all right? Getting the chapter review questions done for chapter 3. And this assignment here is with your other book, that Python programming for the beginning programmer book. In that little textbook, chapter 1 is going to tell you how to download and install Python and how to write your very first program.
Are we ever going to use Code Academy? I saw that on this.
Yeah, we'll use Code Academy.
I've used it a couple.
Have you? And there's good things and bad things about Code Academy. But yeah, we'll use it. We're going to start out with our books though, because it just does a really good job at explaining how to get everything installed and how to get started. So I want you to try this on your own and kind of come in Monday with any questions or problems that you run into so that we can get all of those kinds of things resolved. So when we come in Monday, we'll make sure everybody's got all this working, and we're going to work on these 2 labs. So we'll be working on those together in class. So let's take a look at this week's information. We want to look at this PowerPoint, that chapter 3, developing a program. Now this is the textbook PowerPoint, and I know for chapter 1, we had kind of a different one. For this chapter, there's a lot of things to sort of smush together. So we'll kind of jump around a little bit and use the textbook PowerPoint, because then we're going to get into actually programming with Python, and we'll be not as concerned about the things that the textbook here is showing us. Still super concerned, but not as much so. So in chapter 1, we saw that we have a cyclical approach to software development, right? We find a problem, we work to identify it and design the issues, we code a program to solve the problem, and then we test it. And we just keep doing that over and over and over because we never get everything perfect. Right? So even if we do get everything perfect, something is going to change. So we'll have to change it. So that's our program development cycle. We're constantly cycling through those changes. Now, when we start out, we identify a problem and we have to analyze it. So in this case, they've decided that our problem is we want to generate 6 numbers to play the lottery. So you have to have kind of played the lottery, bought lottery tickets before to understand this one as well. But basically, if you've ever bought any lottery tickets, tell me, would you ever see a ticket like this with all 7s? Is that valid? What's wrong with that?
Don't they have to be like different numbers?
Are they all different numbers? So we don't normally want one number to repeat. That sounds like a good rule to me. Yep, he's on it. What about this one? We have -3, 0, 8, 9, 689, 689. First, we're violating that repeating thing. What else? Do those other numbers look good? A -3, that would be hard to get. What about a 0? Do you think that's okay for a lottery ticket? I don't think it is either. So we have a few rules that have probably been violated in that set. What about this bunch? 1, 2, 6, 47.98765, 88, 93.45. What do you think?
No, the decimals are wrong.
You gotta have decimals. Gotta have only whole numbers. Some of those numbers seem kind of big too, don't they? For lottery ticket numbers. Okay, so if someone told us to just generate 6 random numbers, we could come up with all of these, but that's not enough. That's not enough information for us. We really need more specific information. So we need something that's a little bit more specific, like saying we want 6 different positive integers, because we didn't want decimal numbers, within the range of 1 to 40. So that makes sense. Our more specific scope here identifies what we need to do. A lot better than just saying we need 6 numbers. So the second step then is we design the program. whenever we're creating our design, we want to have it pretty detailed. We want to be able to go back and look at it later and remember what we were thinking. So we're going to use charts and models and pseudocode and anything we can think of to document our design, right? Our algorithms, yep, our problem-solving steps, we need to make sure that they're really specific. So we have some rules. Our algorithms in our design phase need to be well-defined in the right order. We've seen that over and over. Things have to be in the right order. They need to produce some sort of result. And they must get done in a finite time. Yeah, my time limit has to get done today. Some application programs start running and they get done like 3 weeks later, seriously. Third, we're ready to code. We've got an awesome design. We can now start coding our program. We're going to take all of those charts and pseudocode and fancy models we've made, and we're going to convert those into program code. So as we do that, we're going to add some documentation, like internal documentation, external documentation. Internal documentation being comments in our code. And that's why I said that first person who presented for us, that I would bring that up later, said, it's been a while, I don't exactly remember what I did. Exactly, that's why we comment our code. Because if we could remember what we did 3 years ago, we wouldn't need to. But what if somebody else is working on it? They would like that too. And then external documentation, I'll say it a little further on, but that's something like a user's guide. Maybe we have some help windows, things like that. So we're going to get all that stuff put together. Whenever we're coding the program, we're going to use the syntax of our programming language. Will it work? No. Oh, it did. Sort of. What did it do? It just got giant. So syntax. Whenever we're working with our programming language, we have to follow the rules of that language. They have an example here. They say in English, we could say something like, I have put it on the table. And that would be correct syntax, right? Whereas the mouse, I have put it on the table. It would be incorrect for us to say, I have it on the table put, right? Because things are kind of backwards there. Not the same thing, it's not the right order. All the right words are there, but without the proper syntax, the sentence doesn't really make a lot of sense. But if we took that sentence in that order, the way it is, that would be the correct syntax for German. So we can see that we can have some things be really close, but still not quite what they need to be. Fourth, we're going to test the program. When we're testing, we have to be asking questions. Did I understand the data correctly? Does the program fulfill the requirements that it had? Are my formulas or procedures correct? Man, we've been seeing a lot of this stuff lately, haven't we? In the news in the past 6 months or so, we've seen a lot of questions about data integrity, right? We know how important it is to be tracking data. We see very quickly how important it is to track data in the same way, in the same format, every place that it needs to be tracked, right? So we can't just take pieces of information and put it all together and actually get good output. So we have to be thinking about that kind of stuff as we're testing. We're the responsible person. We're the responsible party. Now, when we're testing, we can actually do testing in our different earlier phases before we've coded. So in our design phase, we can use desk checking. So desk checking being me sitting at my monitor, looking at that algorithm, stepping through it, saying, is this correct? And making sure it looks like there isn't any problem. Then when I start coding, I can still be testing. Again, the software I'm using is going to tell me if I have any syntax errors, so I can fix those. But I'm going to have to find logic errors on my own. And the only way I can find those kinds of things is to test my program as many different ways as I can. So if you've ever been a beta tester for a game, you know how important testing is, right? They want as many people as they can to test that application so they can find errors. If we only have the 5 people that were in our development team do the testing, that's a terrible way to test because those 5 people know exactly how it should work and they're only going to use it that way. They don't know how to break it because it's their baby. So we have to have other people test it for us. We have to use good data, bad data, just totally anything that we can come up with. Now, the additional steps they mentioned, sometimes we need external documentation. So if we're going to sell a piece of software, especially, we might need a user's guide or help files to go along with it. We might need an outline of the program. Might need some documentation that talks about the different details of the program. In Springfield, we have a lot of companies that hire students that do sell commercial software. So it could be something that you would run into. Some cities don't really have a lot of companies that sell software, but Springfield does. So we ran back into that idea that the development is a cyclical process. Oftentimes you have to go back to the design and say, this design is all messed up. I can't do this way. This doesn't work. We're missing this piece. We have to adjust to that if there's a problem. And then if we find problems when we're coding, we might have to adjust to those too. Like you might have found them with Scratch, and you said, Scratch doesn't even let me do that. I'm gonna have to adjust my plan a whole bunch. This development environment I've chosen is not gonna meet my needs. So we have to change them. And then testing usually finds additional problems that we have to back up to recover from. Okay, so here's an example program. These are the requirements for it that we were given, and it's called a sale price program. And the company we work for is going to have a sale, and they want to be able to type in some information and have us calculate the sale price and display it for them. So we've walked through a lot of this information. Here's the specifications for us. They say when given an item's original price and the percentage it is discounted, the sale percent, we'll compute the sale price with sales tax. So whenever we look at this document here, the developers, the designers, have looked at these specifications and they've said, we're going to design this from the bottom up. The bottom up means, what are the outputs that I need? Because usually people know that. So if I go into a meeting, I can say, what do you need to see? What kind of output do you expect? And they can usually say, well, I want to see the sale price, the tax, and what the total price is going to be. And then someone bumped in there and said, do you want to see the name of the item? And they're like, oh, yeah, that'd be great. Because if you notice, that wasn't really mentioned up here. But as they were talking about it, they thought, we should probably see that item name also, or we're going to not know what that $35 was for. Okay, so that's our output. We're going to need all of these items to be output. Well, if we want to be able to calculate all this stuff, what kind of input are we going to need to be able to do that? What do we need to know to be able to answer? Well, what we need to know is probably the original price and the amount it's on sale for. And then we can figure that out for you. But we're going to need to do some math. So in our algorithm design, we've come up with all the formulas that we're going to need to be able to do this calculation. When we were coming up with the formulas, we said, we're going to need another variable here that's going to hold the amount we're saving from this thing. So this document is a summary of all of the information that's going to go on with this program. It's not pseudocode, right? It's kind of a summary. So I could have that data in a different format to maybe help me identify things. This is a chart that some people use that's called an IPO chart, an input processing output chart. And it's not anything that's like super fancy, but it can be really helpful. What we have here is just split the area into 3 parts. Over here, we list all of the inputs we need. In the middle, we list all of the calculations or algorithms we're going to take for our logic. And over on the side, we list the outputs. So notice how this IPO chart basically supplies all of the same information that we got from this, right? So I don't know about you, but I know me as a software developer, the fewer words, the better, right? If I can identify the inputs, outputs, and processing without a bunch of narrative, I'm better off because I can just focus on what I need. So if I use this IPO chart, I see exactly what I need just kind of at a glance. So I've decided that I need all of these things, input, processing, and output. Well, as I'm working through my design, I want to keep some things in mind. One of those things is that I want to use modular programming. And modular programming just means I'm going to split logic up into different pieces. And this is one of the reasons we want to look at that Scratch application, because it did such a great job of making modular programs, right? We saw if people associated code with their sprite, they had code module for that sprite. And so we could keep everything separated that way in a nice modular approach. So whenever we're working with our design, we want to be thinking about what our logical program modules are. So for Scratch, some of our modules might be when we click start, that might be a module. Well, for this application where we're going to just be asking for data and doing a little bit of math, our modules are going to be more like ask for input, process the calculation, and then output. So we'll have input, process, and output modules. We could also have sub-modules, modules that are called by modules, and we can keep creating subsets so that we keep breaking pieces down into simpler parts. What we would like in the end, the perfect world would be each module performs a single task, like one thing. Each module is self-contained and independent. And you guys really saw that with Scratch. You saw that with some of the applications where people had been able to really implement that modularized approach, that this module only worried about displaying this one little message. And that's how we want modules. We would like them to be really short. This example says statements should not exceed 1 page for a module. Well, that's pretty relative, right? What if I'm using a really small font? I could fit a lot more on a page. Some programmers say a module should be less than 20 lines of code. Some people say 5 lines of code. I would never give you a limit like that. I would say a module should be short and it should contain exactly as much code as it needs to be self-contained and independent of other modules, right? So we can't make a rule about that. So some benefits. First of all, it's a lot easier to read those programs, right? The ones that were modularized, we could just find that little chunk of code and see what's going on with it. Our top-down programs, they were easier to create, but when we look at them after the fact, they can be a lot harder to find the specific area that we need to change. So modular programming is easier to read. It's easier to test the program one module at a time. We can do all that stuff separately. The other thing is we can split up the workload. So if I was going to write this massive Scratch game and I had all of these different sprites, I could say Joe's responsible for the code to go with this sprite, Damien's responsible for the code that goes with this sprite, Jill's responsible for the code that goes with this sprite, And as long as we all know what our rules are, we should be able to fit all those pieces together after we've done all the coding, right? So modular programming lets me have multiple developers. And I could maybe reuse the module, right? If I have a module that's really effective, like that figures out how to move a sprite, I could use it over and over. So modules, good. So here is our sale price program with some module ideas. This is sort of a pseudocode. You can tell it's not all the way exact pseudocode. It starts out saying, we're gonna have an input data module. It's gonna prompt for our stuff and then input our input. We're gonna have a calculations module. And in that module, we're gonna do all these calculations. And we're gonna have an output results module that writes out all of our outputs. So not too different of a thought, just kind of organizing things. So that first option wasn't really specific pseudocode, it was kind of general. Well, here's the more specific pseudocode. So now we see an actual write statement for each prompt and an input statement for each variable. So just a little bit more specific of pseudocode. In our output module, we've got some nice narrative for our fields so that we know what they are. So when I call a module, what happens? Well, I'm going along here and I'm executing this code. The processor is reading a line of code, executing it, reading a line of code, executing it. It's going through our module A and it's reading code and executing it. When it gets to this line where it says call module B, the processor stops at that point and says, I must branch control to module B. Okay, so I'm running module A and then I branch to module B and I start running the lines of code in module B. When module B gets to the end, it's done. It says return, control, return back to that original module and just continues on. Okay, so module A calls module B. We jump over and start executing it. Module B gets done. We just return back and continue on in module A where we were. So we need something that calls our modules. In our little pseudocode example, we said we're going to have all these modules. How do these modules get called? We're going to do that with a main module. So most programming languages have a main, and the main module is the starting point of the program. We'll see with Python, we'll have to kind of create our own main, but we'll do that to make it happen. So in this example, the operating system starts running our sale price program. It says, oh, to run this program, I have to find the main module. Here it is. What does my main module say to do? My main module says, call the input data module. So that module is going to run. When it gets done, control return to the main module. The main module then says, perform the calculations module. That calculations module will run. When it gets done, it'll return control to the main module that will then call the output results. Output results will run. When it gets done, it'll return control and we'll be at the end of our main, so our program will be done. Now, as a side, we saw in our output module pseudocode that instead of just saying write some number, we said write a message with some number. So whenever we add more information to our output like that, we're just making it clearer. So all our modules can be illustrated using a hierarchy chart. So here's a hierarchy chart. It's really simple. right? All it has are these rectangles, and it has a rectangle for every module in the program, every subprogram. So in this example, my main module calls module A, module B, and module C. The hierarchy chart does not give me an idea of what order they're called in, what dependencies there are, just the fact that they're called. That's it. Now, when I look at this module B, also calls module B1 and module B2. So all this shows me is what module calls other modules. That makes sense? It doesn't give me any sort of input into the logic or anything like that. I just know that if I change module B1, I'm going to be affecting module B and potentially the main module. So it's a map that tells me what affects what. Hierarchy chart on the test, on every quiz, on every exam, hierarchy chart. You guys all look at me. Everybody just looks at me like they don't believe it. Okay. So we did all that design again. We're ready for our coding, documenting, and testing. In our book, they do all pseudocode throughout this whole Prelude to Programming book. We're going to add and do some Python so that we don't just do pseudocode. And they mention the comments and documenting again. Two kinds of comments that we're concerned about internally within our program code. First, our header comments. They are at the top, and they tell us an overview of the program. And the other type of comments that we want to see are step comments or inline comments. I'll show you some. Here we go. Here's an example. Up here at the top, we have the header comment. So it's giving us information on the program, the author, and when it was written, that sort of overview information. And then down within the code, we see the inline comments. So the comments in this programming language start with 2 slashes. In this one, we see the programmer, the author. And I know I worked for a company years ago that is a major corporation. It's called a Fortune 500 company. And that means it's one of the 500 biggest companies in the country. And when they were audited a few years ago, they were told that they had to take this developer information out of all of their header comments. So they had to go through and change all of their code to remove those because the auditors felt like there was some sort of personal danger or something with them knowing who the original developer was. So you might work for a company that says you can't put that kind of information in your comments. You might work for a company that requires you put that kind of information in your comments. It's going to be dependent on the company. Now, like I said, with our test data, we want to make sure that everything is being tested. We're testing good things, bad things, in between things. We're going to use desk checking to walk through our code and make sure that everything looks good. Try to test as many ways as we can. So what if we find errors? We have 2 kinds. First of all, syntax errors are where we're writing our code and we don't follow the syntax rules for our programming language. It could be something like having a word spelled wrong, or in the word, like in Python, we can have the word input spelled with an uppercase I, and it needs to be a lowercase I. All of those kinds of things are syntax rules, and they can keep us from running our program. If we have syntax errors, we can't run. But we can have all our syntax errors fixed and still have logic errors. So if I run a program that's supposed to, let's see, the one this morning, they created a game, and the answer, I know from all the times I've watched the game, has to be an even number, and it has to be like below 8. And as one guy was demonstrating his code, he typed in the answer of 10 and it took it. So I didn't have to say anything, but I knew just from watching him run his program that that was a logic error, that there was no way the number 10 could be a winner with that game, the way it's set up. So that logic error didn't cause any problems in the program. It's just wrong. You know what I mean? It's just not got the correct result. Now, it could have caused problems, though. Sometimes if we have a logic error, it can actually cause our program to cancel. And then that would be a runtime error. So a logic error is our logic is flawed and does not produce the correct result. If it cancels, it's also a runtime error. And you've probably had websites and different things that have crashed on you like that. Nobody likes a runtime error. These are important things for us to find in our testing phase. I keep saying this about our external documentation. They keep coming back around to it. If we were selling software, we'd have a user's guide or a maintenance manual or something we might have to work on. And the user's guide is usually written by a technical writer. Every once in a while in our field, we get people who really like explaining how things work to others. They enjoy that, they like helping people, but they don't really enjoy writing code themselves, but they like analyzing other people's code. Those people would be great technical writers, because if they could go through code and come up with a manual to help others, you know, that's really important. That's a really high-paid job, because that's somebody who can understand code and create documentation. So something that doesn't come along every day. Now, we also might need documentation for other programmers. So for the other programmers, maybe we need some sort of maintenance manual to tell them, you know, every 5 years you better do this or whatever. So other things we might need would be like trade study documentation, research, things that show how attempts were made to find the best solution. An area that might be important for that would be if our company came to us and said, what's one that's been in the news lately? Oh yeah, we need to find a new system to process unemployment claims because ours was written in 1978 and it's not keeping up. So if they came to us and said that, and we went back to them and said, here, this is the system that I believe we should purchase. It's the system that 17 other states have just bought. We better keep track of all that research for when that comes back to us with people asking, why did we spend all this money on this system? Well, because we looked at all 5 of these systems and this was the only one that met our needs. So think about that kind of stuff. When we're doing research, we need to keep documentation on that to show others why a decision was made. We saw that we have to do structured programming, write our code in subprograms. And that gets us to flowcharts. Phew, that's where I went and just stopped today. Thank goodness. So next time we'll look at the flowchart section and learn about doing those. So in our module section, when we come in on Monday, we'll check in with everybody, make sure that you are able to get Python installed. We'll talk about flowcharts, and then the rest of our day, we'll work on these 2 labs. And these will be with your study group. You can take a sneak peek, but it would be best if you just waited to work with your study group on those on Monday. So do the on your own assignments. The lab ones we'll do on Monday. Any questions before we get out of here? Whew, we got a lot done today. Good job, you guys. Where are you out? Next time we'll have mostly lab time, so we'll make up for it. Have a great weekend.